In this activity, we're going to investigate the power of exponential functions by folding paper. Have you ever heard the tale that you cannot fold a piece of paper in half more than 6 or 7 times? You should try it. I promise you can. But what would happen if you could? It's only paper, right? So first we're going to brainstorm some ways that we could measure the thickness of one sheet of computer paper. Pretend that Googling it isn't an option. What are some ways you might be able to do that? I could take a ream of paper, or more than one ream, measure the height of the ream, and then divide by the number of sheets of paper in the ream. If you're going to do it this way, don't forget to include the sheets of paper that are parts of the covers as well. But since we don't have those reams of paper, instead we can just Google it. The internet told me that a ream of paper, a single sheet of paper, is 0.004 inches thick. So now let's think about how many layers of paper there are depending on how many folds we have. So if you can picture a single sheet of paper, then that has one layer. Imagine if you fold your piece of paper in half once, how many layers would there be? There would be 2, which means my total thickness would be 0.008 inches. 0.004 for the first layer and 0.004 for the second layer would make 0.008 inches total. Now let's fold that piece of paper in half again. Grab your piece of paper, now you've folded it in half twice. So my paper has 2 folds. How many layers are there? Count those layers and you're going to see that you have 4. Since they're 0.004 inches each, that would be a total thickness of 0.016 inches total. Now let's assign some variables. There's a typo here, so I'm going to fix it. Let's use the variable f to represent number of folds and the variable t to represent total thickness. We're going to fill in the table below, and then we're going to complete it with ordered pairs in f, t format. One ordered pair is going to represent the total thickness of the paper with no folds, one ordered pair with 1 fold, and one ordered pair with 2 folds. So based on the information above, when we start with a single sheet of paper, it has 0 folds in it, which means that it has a total thickness of 0.004 inches. This ordered pair would be 0.004. After 1 fold, there were 2 layers for a total thickness of 0.008. And after 2 folds, there were 4 layers with a total thickness of 0.016. Let's pull in for a second to estimation station. Look at an earbuds case. How high do you think it is? We're going to estimate using inches. A good estimate for an earbuds case might be 1 inch. Now look at a desk. About how high do you think it is? Again, we're using inches. Don't stress, just guess. I want you to do the same for a door. So fill in these 2 empty spaces with your best estimate for the height of a desk and the height of a door measured in inches. So my estimate for a desk was about 30 inches. It looks to be a little less than 3 feet. 3 feet is 36 inches, so I went with 30. If yours is different, that's totally fine. A door, I kind of looked at it and said, I think a person that's 6 feet tall could walk through comfortably, so I might measure to 7 feet. 7 feet times 12 inches would be 84 inches, and I just rounded to 85 just because it seemed like a better number than 84. Now for a football field, if we know that a football field is 100 yards and 1 yard equals 3 feet, this would mean that a football field is 300 feet long times 12 inches per foot is going to give us 3,600 inches for the length of a football field. Now let's use these estimates to think about how many times we would need to fold a piece of paper in order to reach these heights. So we estimated an earbuds case to be about 1 inch tall. Now remember, according to our previous table, that after 2 folds, which was 4 layers, our paper was at a height of 0.016 inches. A desk we're estimating to be around 30 inches tall. Again, yours might be a little bit different. A door, I measured 85 inches, or estimated. And a football field, this would be 3,600 inches. So at this point, you're going to pause the video and you're going to think about the number of times you would need to fold a piece of paper in half, if it were physically possible, in order to reach these various lengths or heights. So try to think to yourself, would I need to fold the paper 5 times? Would I need to fold the paper 20 times? Whatever you think is a reasonable estimate for the number of folds, you're going to enter this information here. Pause the video, go ahead and do that. So at this point, you're going to have different numbers of folds entered into this area based on what you think you're going to have to do for the folding paper. I might guess that maybe I'll need to fold the paper 5 times. Here to reach a desk, maybe I'll need to fold it 40 times. Then to get to 85 inches, maybe I'll need to fold it 100 times. And for 3,600 inches, that seems like a lot. Oh gosh, maybe I need to fold it 1,000 times. Now, of course, these things aren't possible, but we're just pretending they are. So now let's look at our data a different way. We're going to fill out some information and write some numbers, but in different formats. Later on, we're going to be entering this data in a spreadsheet and using formulas and autofill to have it do the work for us. So if I just take a single sheet of paper, I know that that has 0 folds. Then if I fold it in half once, it has 1 fold. Twice, it has 2 folds, so on and so forth. So I'm going to fill in this table up through 5. Now I know that if I fold the paper in half 0 times, just look at a single sheet of paper, that has 1 layer to it. If I fold it in half once, it has 2 layers to it. So I want you to pause the video and enter the rest of this data for the number of layers, depending on how many times you fold your paper. If you're not sure how many layers it has, actually do it with a piece of paper and see. Might be kind of hard when you get to 5. Pause the video now, press play when you're ready to check your answer. So after 2 folds, the paper will have 4 layers. After 3 folds, it will have 8 layers. After 4 folds, it will have 16 layers. And after 5 folds, it will have 32 layers. So now we're going to write the number of layers, this number right here, using repeated multiplication. So that means something multiplying itself over and over. Can you see what number is being multiplied over and over? You might have figured out that it has to do something with multiplying by 2. I'm actually going to start with the 4. 4 I can write as 2 times 2. Well, 8 I can write as 2 times 2 times 2. Pause the video at this point and complete the rest of the table that you can. There might be a few boxes that you leave blank. We'll get to those together, I promise. So for 8, we can write that as 2 times itself 3 times, 16 is 2 times itself 4 times, and 32 is 2 times itself 5 times. 2 is just 2. It's not multiplying anything. You might be wondering, how do I show repeated multiplication to get the 1? This part's just a little bit tricky, but we're just going to write it as 1. Interestingly enough, I can add that same 1 in here for all of these things, because remember, multiplying by 1 doesn't really change anything. So it's really starting with 1, and then we're multiplying by a different number of 2's each time. So 1 is just 1, 2 is 1 times 2, 4 would be 1 times 2 times 2, and so on. Now let's try to take the number in the expanded column, and instead of writing it in expanded form, let's write it using an exponent. So what I could do for 2 times 2, let's say, well, I know that 2 times 2 means 2 squared. And so this would be like saying 1 times 2 squared. Do you think you could fill in the rest of this table? Fill in as much as you can, pause the video now, press play when you're ready to check your answer. So one thing that's interesting is our exponent is going to match the number of 2's that we have, and I still have my coefficient of 1 out front. Now this one, you might have filled in on your own, which is great if you did. But since I don't have any 2's, I could think of it as I have 0 2's. Remember that anything to the 0 power is 1, and 1 times 1 would be 1. So on this next table, what we're going to do is we're going to fill in the number of folds, but then we're going to focus on the total thickness. So number of folds, again, if you look at a single sheet of paper, that has 0 folds. Fold it once, it has 1 fold, then 2 folds, 3 folds, 4 folds, and 5 folds. The number of layers we can copy from the table above, 1, 2, 4, 8, 16, and 32. So this time I want to focus on the total thickness. So if I have 1 layer, that means my thickness is going to be 0.004 inches. 2 layers means I have 2 of those, 0.008 inches. 4 layers was 0.016 inches. Use your knowledge that one layer of paper is 0.004 inches to fill in the remaining 3 boxes. Pause the video, press play when you're ready to check your answers. So here you can see the thicknesses for the different layers of paper. Hopefully you noticed that a quick way to do this was to take the number of layers and to multiply by the thickness of one sheet, which was 0.004. Later on, we're going to show you how to write this as an exponential equation.